All right, so we're going to start with our Formula 4 from kinematic equations. And we're going to use some other laws, Law 2 formula. And we're going to show you that the work kinetic energy theorem formula comes from this. So we'll start with Vf squared equals Vi squared plus 2AD. All right, now it's some math magic time. All right, first thing I'm going to do is multiply everything by m, the mass of an object. Right? Mathematically, as long as I multiply everything, I keep the equation balanced. Everything's just going to get m times bigger. So then I'm going to have this, m Vf squared equals m Vi squared plus 2 m a d. So all I did was multiply everything by m. Now I'm going to notice that I'm going to substitute F equals ma. Because I have an m times a, I'm going to make that an f. So now I'm going to have m Vf squared equals m Vi squared plus 2 f d. Okay, so all I did was substitute f in for the ma, because f equals ma. One more board here. What's FD equal to? What's force times displacement equal to? Work, right? So I'm going to substitute again. Right? Work equals force times displacement. So now I'm going to have mvf squared plus mvi squared plus 2w. 2 times work. Ooh, somebody's knocking at the door. Yeah. Can I finish this quick? Okay. Give me a couple minutes. Okay. Come back. Or just wait. All right. So now it's time for math magic. I'm going to subtract this mvi squared from both sides. Get squared, oopsie, subtract. So all I did was subtract mvi squared from both sides. Now, I'm going to divide everything by 2. Right, so I divide everything by 2. This becomes a half, and w. What's this look like? 1/2 mv squared. Kinetic energy, right? That's the definition of kinetic energy. Definition of kinetic energy. Right? Definition of kinetic energy is 1/2 mv squared. So if I've got 1/2 mvf squared, that's the final kinetic energy, minus the initial kinetic energy, equals work. And what's our definition when we do final minus initial? What do we call that? The final amount minus the initial amount is the change in, right? So this is the change in kinetic energy is equal to the work. So the work kinetic energy theorem just came from our kinematic equation from chapter 2. Okay.